Drive across the American Great Plains today, and you will unknowingly pass the remnants of the largest abandoned food forest on Earth. In the 1930s, the United States government planted over 200 million rugged shrubs in a desperate, continent-spanning bid to save the country from ecological collapse. They created a living wall that stretched for 18,000 miles. The plant they chose produces a crop with the exact protein content of modern soybeans, requiring zero synthetic fertilizer, zero replanting, and zero irrigation. Yet no one ate it. We planted an agricultural miracle to save our dying soil, but we completely ignored its ability to feed our people. This is the story of the Siberian Peashrub, a perennial protein powerhouse, and how the rigid demands of industrial mechanization and capitalist commodity markets left it behind in the dust. Welcome to Ancestral Yields. If you want to uncover the lost crops of history, make sure to like this video and subscribe. The rugged biology of the Siberian Peashrub, scientifically known as Caragana arborescens, is a direct result of its geography. It is native to the harsh, unforgiving climates of Siberia, Manchuria, and the wind-swept steppes of Mongolia. Historically, this plant was not a mere botanical curiosity. It was integrated deeply into the survival diets of indigenous nomadic tribes and rural populations across Eastern Europe and Northern Asia. In the high-altitude regions of the Altai Mountains and the freezing Siberian plains, during severe winters and devastating periods of famine. When traditional grain crops withered in the early frost or died in drought, the seeds of the peashrub were relied upon as a critical dietary staple. In a barren landscape where calories were incredibly scarce, the plant provided the essential fats and heavy proteins required to keep human communities alive. Traditional preparations involved boiling the pods and seeds to soften them, creating a nutrient-dense porridge that sustained families when the wheat harvests failed. The plant's journey to the United States is a fascinating chapter of agricultural history. While early European immigrants brought handfuls of seeds in the 1750s, the true champion of the Siberian peashrub was Niels Ebbesen Hansen. In the late 1890s, Hansen was commissioned as the United States Department of Agriculture's first official plant explorer. His mission was to travel to the frozen, remote steppes of Siberia to find cold, hardy, drought-resistant crops that could survive the brutal, sub-zero winters of the American Dakotas. Hansen observed nomadic herders and rural farmers relying on the peashrub in conditions that mirrored the American Midwest. He brought the seeds back to the United States not just as a curious hedge, but recognizing its immense historical value as an agricultural insurance policy. A low-maintenance, high-protein feed for both human survival and livestock. For a brief window in early pioneer history, championed by agricultural scientists, it seemed poised to become a staple of the American homestead. In 1934, the United States faced an ecological apocalypse. The catastrophic wind erosion of the Dust Bowl was stripping the Great Plains straight down to the bedrock, turning former prairies into barren wastelands. In response, President Franklin D. Roosevelt, alongside forestry visionary Raphael Zahn, launched the Prairie States Forestry Project. It was a desperate, monumental task. The government organized the planting of 220 million trees across 18,000 miles of the American heartland, from North Dakota all the way down to the Texas Panhandle, to create massive shelter belts. Because of its extreme drought tolerance, its immunity to freezing temperatures, and its deep, soil-stabilizing root system, the Siberian peashrub was selected as a primary frontline species for this massive undertaking. Millions of these protein-dense shrubs were planted specifically on the windward outer rows of the shelter belts. Their dense branching habit was perfect for stopping ground-level winds and trapping snow to return moisture to the parched earth. However, This led to a massive economic paradox. The American agricultural infrastructure, from the massive grain elevators to the transcontinental rail cars, was entirely built around and dependent on the commodity markets of annual cash crops, specifically wheat and corn. Therefore, the pea shrub was classified strictly as a utilitarian tool by the government. In the USDA circulars and forestry bulletins of the 1930s and 1940s, it was cataloged solely under erosion control and wildlife food. It was viewed as a living wall to protect the soil so farmers could continue growing and selling wheat. So what exactly did the government plant, and what nutritional goldmine did they overlook? The Siberian peashrub is not a delicate annual vine that requires trellising and constant irrigation. It is a perennial, leguminous shrub or small tree that thrives effortlessly in USDA hardiness zones 2 through 7. It acts as a nitrogen-fixing biological fertilizer factory, utilizing a symbiotic relationship with soil bacteria called rhizobia to fix atmospheric nitrogen directly into the earth. It survives extreme conditions that instantly kill traditional cash crops, enduring severe droughts, highly alkaline or saline soils, and deep winter freezes down to -40 degrees Fahrenheit. It does not require rich topsoil to survive. It actively builds it. But the true marvel lies in the nutritional profile of its seeds, which present a macronutrient anomaly for a tree crop. Lab analyses show that the dry seeds contain approximately 36% protein and 12 to 14% fat. To put that into perspective, using specific measurements, for every 100 grams of dry seed, which is approximately 3.5 ounces, you are getting roughly 36 grams of pure protein and up to 14 grams of healthy fat. A standard green garden pea contains a mere 5 grams of protein per 3.5 ounces. The Siberian peashrub directly rivals the modern commercial soybean, which averages 36% protein and 18% fat. Furthermore, the pea shrub delivers substantial mineral density, offering an estimated 120 milligrams of calcium and over 800 milligrams of potassium per 3.5-ounce serving. But unlike the soybean, the pea shrub achieves this remarkable nutritional density without the massive inputs of synthetic nitrogen fertilizers, chemical pesticides, heavy irrigation, or the destructive annual tilling required by commercial monocultures. If it was so historically prized and nutritionally dense, why is it not grown as a food crop on every farm in America today? The answer lies in the plant's fierce biological independence. The biggest obstacle is processing and detoxification. Raw Siberian peashrub seeds contain L-canavanine, a non-protein amino acid that acts as a natural insecticidal defense for the plant. Eaten raw, the seeds have an acrid, almost turpentine-like bitterness. They are highly unpalatable and mildly toxic to humans, causing severe digestive distress. To be safely consumed, this compound must be systematically neutralized. Because L-canavanine is highly water-soluble, proper preparation is non-negotiable. Harvested seeds must be soaked in cold water for a minimum of 24 to 48 hours, with the water thoroughly drained and replaced several times to leach out the toxins. After soaking, they cannot be lightly simmered. They must be vigorously boiled in fresh water for at least an hour, or processed in a pressure cooker, much like raw kidney beans or soybeans. For maximum safety and flavor, culinary pioneers often follow this boiling step with long-term fermentation. Because it required this intense, traditional kitchen labor, the pea shrub was eventually shunned in favor of modern convenience foods that could be eaten straight out of a box. Cautions. It is also critical to note that because of the presence of L-canavanine and its nature as a wild legume, certain individuals should absolutely avoid consuming it. Anyone with severe peanut or soy allergies, pregnant or nursing women, and individuals with autoimmune conditions such as lupus should not eat Siberian Peashrub seeds, because improperly processed L-cannabinoid has been linked in medical literature to triggering autoimmune flare-ups. Second, and more importantly, is the harvesting barrier. As the seed pods ripen in late summer and early fall, they rapidly dry out under the intense sun. Upon reaching maturity, the pods violently twist and shatter, aggressively ejecting the seeds onto the ground in all directions. This explosive seed dispersal is an evolutionary triumph for the plant, guaranteeing its spread. But it is an industrial nightmare. A massive combine harvester cannot process a crop that randomly throws its yield into the dirt over an unpredictable period of weeks. Because the pea shrub resisted mechanization and required patient, localized hand harvesting, it was entirely abandoned by commercial food agriculture. If you plan to forage, there are no highly deadly lookalikes that share the plant's distinct yellow snapdragon-like flowers and pinnate leaves. However, a critical rule remains. Never forage in random areas near highways or at the edges of conventional farms, because these rugged shrubs are often heavily sprayed and exposed to herbicide drift. Instead of foraging, you can easily cultivate this biological engine at home. You can source seeds or bare root seedlings from reputable conservation nurseries like Sheffield Seed Company and Earthseed Care. To plant from seed, simply soak the hard outer shells in warm water for 24 hours to break their rigid dormancy. Plant them about ½ an inch deep in well-draining soil in full sun. If you are creating a dense, living hedge, space the seedlings about 3 to 5 feet apart. During their first growing season, they will need to be watered deeply about once a week to encourage their massive taproots to drive downward into the subsoil. However, once that first year is over and the root system is established, you can put the hose away. The Siberian Peashrub becomes virtually invincible to drought, requiring absolutely no supplemental watering and 0 soil amendments, thriving entirely on whatever natural rainfall your climate provides. Just give them the space to establish, and within 3 to 5 years, you will have a permanent, self-sufficient protein factory in your backyard. The story of the Siberian Peashrub is a profound testament to the limitations of industrial farming. We traded a self-fertilizing, perennial protein source for annual crops that require constant chemical life support, simply because our machines could not catch the seeds as they fell, and our markets could not figure out how to box them. This is a plant that outsmarts the machine. It demands localized, integrated farming rather than vast, sterile monocultures. If you're ready to fill your garden with crops that history forgot, give this video a like and hit that subscribe button for ancestral yields. We have more forgotten harvests to uncover, and the best way to build true resilience is to grow your own. See you in the garden.